Hi, my name is Josh Glass, and I'm an architect here at Skellig. I've had many great achievements over the past years in my career, but I think the coolest was winning the Firebrand Award this past year at Ignition's ICC conference, which you can kind of see blurred out over there. But I've been doing this a pretty long while and have read a lot of different things, and one of the organizations I follow is the CSIA, which stands for the Cybersecurity and Infrastructure Security Agency. Part of what they do, well, they're part of the Department of Homeland Security in the government. And part of what they do is they have a spot for different companies to post when their control systems and software have different security advisories or alerts that they need their customers to know. And, in good ethics, publishing when they might have a security vulnerability of their software. They also give you advice on what to do to mitigate those vulnerabilities and how to patch anything or any mitigating tasks you can do until you can make those updates. But one of the most interesting ones to me recently was a specific control system stated that you should, and I'm quoting, encouraging users to remove connectivity on all industrial control systems devices connected to public-facing internet to reduce exposure to unauthorized or malicious cyber activity. What that basically is saying is, in a nutshell, is you should remove the control systems from your internet network or any network that touches the internet, which most times is the business network in companies. But there's a lot of reasons why you might want to keep that system on that network. Maybe you want to get data from it. Maybe you need to have some kind of monitoring of it. Maybe you just need to have the historical values. A lot of different reasons, and no one's going to be updating these systems any day soon. But I think there's still some ways you can use technology, the modern technology, to update the control system to today's standards, even without going through a whole change of everything. While that might be the last option too, that I'll talk about at the end of the video, I think there's a couple other ways you can update your control system to work with today's modern infrastructure, all while getting the benefits of modern cybersecurity to reduce any attack vector. The first thing you can take a look into is the firewall rules. A firewall enables rules to be put on the network to tell traffic whether it can keep going or it's stopped by the firewall. And one way to implement rules is you can let traffic come out of a specific network or IP address, but not let traffic go back in, or one-way rule. That means anything coming out from that network or that device will come out, travel as normal, but anybody going back in, whether you're trying to come from internal directly on that network or external from outside of that network, which is where all of our attackers come from, and that blocks that traffic from going directly down. It means that it closes all of those ports or anything that an attacker could try to get to. There are still, traffic coming up, so there's still some ports open and some network chatter going back and forth and it making requests. So there could be something that's a little bit more sophisticated that gets in there to get your control system and, remotely do anything to it. But the one-way rule really reduces a lot of risk that you could have from not having that rule in place. So that's the first easy rule or change you could make. And the great thing about it is an average IT guy should be able to make that change for you, and you'd see the benefits pretty instantly. So you don't need any special training or anything. It's just plug and play and you're done. And that should help reduce your attack vector a lot, all while keeping your monitoring in place and the data coming up, because it's still coming up so you can still see it. The next thing you should look into is an edge node. An edge node is a computer type device, either a virtual machine or a physical computer, that enables the two different networks or two different devices to talk together or be bridged together. Edge nodes are being used a lot more in the 4.0 ecosystem as places where you can deploy it directly as close to the equipment as possible to collect data, do what we need to do, and get that data securely back to your central hub, because that edge node is a modern device built with modern firewall rules and modern certificate ability, so you can create secure encrypted communications between that edge node and any other device it's communicating with. So it can be a lot more secure to get that data from that control system that might not have those abilities built into it, but we need today. And the great thing about it is that Edge Node is able to communicate with all the different protocols that we're used to, be it Modbus or OPC or whatever. You can have that program installed on the Edge Node to communicate with that legacy control system, and then that Edge Node is where the rest of your network will interface with to get access to it. And the great thing about it is because the communication's going through the Edge Node, you can enable that remote control ability. It still, should be secure, password protected, make sure whatever control system software you're using isn't hackable. But it's another way that you can still be able to have all the capabilities of what you're used to with your legacy control system today. And again, not have to have a lot of changes to what it currently is, but still meet all of the things we need in today's world to be able to do our day-to-day business. The other downside, I guess, to it as compared to the firewall rule is, yeah, like I said, it sounds more complicated. So you need someone who knows edge nodes, who knows OT, who knows IT, and can enable that type of communication in the right way so it is secure and it's not set up in an insecure way that could open up more risk. The last way you can solve this problem is, like I said at the beginning of the video, just start with a blank slate and pretend your control system doesn't exist. Start with modern hardware. Some PLCs today have firewalls and certificates built right in, so they can act as edge nodes, or if not, just even have that filtering ability to make sure that everything you expect to go through that PLC is going through, and everything you expect to not work will not work. And keep that control system secure. It is the most costly, the most time consuming, but it's the only way to know in today's day and age that your control system will be secure for days to come, because it is modern and hasn't been mothballed and had parts discontinued, where you need to go to auction websites to find where they might just hope that someone listed them, and keep that legacy control system chugging along in hopes that it remains. So maybe you just need to cut your losses and start from scratch. At the end of the day, the only way to make sure your network's secure is to make sure everything is as disconnected as possible, or in layers down from the internet as possible, using different methods such as demilitarized zones, air-gapped network, different VLANs, and a whole lot of other capabilities we have today to make your network more secure. But the legacy control systems are never going to get updated to the standards we need today. So we need to act now and figure out a solution, because people are attacking our core infrastructure from this kind of systems being online because there's not enough people to maintain them. So they just need the capability. The end users are just trying to get by, but we need to help figure out a solution. So I hope some of these ideas can help give you something to move forward or just start a conversation. All right. Hope you enjoyed this conversation, and thanks for listening.